Okay, today we are still working with secants and tangents, but we are looking at finding different lengths of segments in a circle. So those segments might be part of a secant, part of a tangent. It might use problem solving to find a missing radius or diameter. So you're finding segment lengths today, but we're still gonna see properties between secants and tangents. So more properties or theorems to keep track of. The first set of examples, so on this first side are all segments that intersect inside of a circle. So if two segments intersect inside of a circle, the relationship in the lengths of the segments. So it says if two chords intersect in a circle, then the products of the lengths of the chord segments are equal. So I have a circle here. I have a formula that represents what that says. So notice this one chord, if we think of this part of the chord as A, this part of the chord as B, and then for the other chord, we have this part is C, this is D. So you're multiplying A times B, so the product of those two segments should equal the product of the other two, should equal C times D. So you're multiplying the two segments that are from the same overall chord and setting those equal. So in those first two examples, if we look at the first one, example A, it says to find x for both of these. And we have the different segments labeled. So for segment AC, one part is 5, one part is 12. So I would have 5 times 12 is equal to, and then for ED, we have x times 10. And we're solving that for x. I'm just going to rewrite this. 5 times 12 is 60. I can rewrite x times 10 as 10x. And you could have written this, right away. And then to solve for x, I just have to divide by 10. So x in this case is 6. Okay, so the products of the segments that form each chord are equal to each other. All right, so go ahead. I'm not going to walk around because it'll probably be quicker, but go ahead and do B on your own, and then we'll just check it. Find x for B. Actually, I think I want to stick walk around and double check it. Thank you. Yeah. I just grabbed a different sheet because I had already written it down. The answer, we're going to go through it. I just wanted to see what you guys got. The answer is 6. So here's how you get 6. So you have this chord. Your attention up here, please, because a couple of you had 6, but a lot of you didn't have 6. So you have this chord, which is split into x and x. So you would have x times x, which then for this side, what is x times x? X squared. So make sure when you're multiplying x and x, it's not 2x. And then you have this part is 2. So a lot of you did 2 times 10, which I can understand because you have the 2 here and then this 10. This 10, though, is just the radius. It's not this whole thing. So if the radius is 10 and this part is 2, that means this part is 8. So this whole part is 18. So you're multiplying the 2 by the 18, which is 36. So you end up getting x squared equals 36. And then you solve by square rooting each side. So x is 6. Okay, that one a little tricky, but look for things like that. I know it's easy to look at that and just do the 2 times 10, but look to see if you have the entire length of something. All right, the next 2 examples then. If we look at what is labeled as example 1, so problems like these will be given where you have some sort of object, or it could be part of some sort of architecture that is creating part of a circle. So it says the true shape of a rainbow is a complete circle. However, we only see the arc of the circle that appears above the Earth's horizon. So it's showing a rainbow, and then you see where the horizon is. So really there's a full circle that you're not seeing. So off to the side, a full circle is drawn here, and this part from A to C, this is representing the rainbow. Okay, so when you're comparing these two, that's representing the rainbow. It says, what is the radius of the circle containing the arc of the rainbow shown? So our answer should be the radius of the circle. We're finding the radius. There's other things we have to find before we can find the radius, but that's ultimately what we're looking for. So to help you, what this is showing is that the peak of the rainbow is 0.7 miles above the horizon. And then it's showing the width of the rainbow, the part that we can see, is 5 miles long. So if we were to draw this into a full circle, so in example 2, notice nothing is drawn. So you might have to take a picture like this, draw it out or sketch it, and then make the full circle to label it. But you can see here's the rainbow, here's the 0.7. And then here is the width of the rainbow that we can see, which would end up being a chord of the circle, 5 miles long. And when it says AC, so I had just given this to you, AC is a chord of the circle. So that's the horizon or the width of that rainbow. And then DB, the 0.7, that ends up being a perpendicular bisector. So that's why the 5 miles is split into the 2.5 and the 2.5. So now in our method to find the radius, what we can find is, in order to know the radius here, really what I'm going to have to find first is the full diameter. So I can label from B all the way to E, that whole thing I can label as X. And I can use the property we just talked about by finding the products of the parts of each chord. So I would have the 2.5 multiplied by 2.5, so 2.5 times itself, and that should equal the 0.7 multiplied by X. So 2.5 multiplied by itself is 6.25. And that's going to equal 0.7x. And then I can solve for x, divide by 0.7. So x is, and I'm going to round this because you should get 8.92857 and so on. I'm going to round to 2 decimal places. So I'll do 8.93 approximately. And that's not my answer because I want to find the radius. So now that I know x, I can find the length of the whole diameter. So the diameter of that circle is the 8.93 added to the 0.7. Which, again, I'll keep that, well, I already had rounded this. So that would be 9.63 approximately. So I had approximated the 8.93. And then once I have the diameter, I can just cut that in half to find the radius. So the radius would be that divided in half, so approximately 4.81. And then because all of these measurements are measured in miles, it'd be 4.81 miles long would be the radius of the circle that is created by that rainbow. Okay, so looking at what are you able to find, and then how can that be used to find what the question is asking for. So we actually had to find x and then the diameter in order to find the radius. We can't just jump straight to the radius. Questions on that one? Okay, so then let's just work through example 2 together also, because this one you have to sketch by yourself. So it says the highest point or apex of the Astrodome is 208 feet high, and the diameter of the circle containing the arc is 710 feet. How long is the stadium from one side to the other? So I'm going to first sketch the stadium. So the sketch is going to look similar to this. This is the kind of shape we're looking at. Say you have a stadium, here's the ground, and then the Astrodome is created by part of a circle, and it's saying the highest point or the apex is 208 feet high. So at its highest point, this length is 208. And then it's giving us the diameter, but this here is not necessarily the diameter. It doesn't tell us that the ground level is exactly where the diameter of that circle would be, so you can't put the or label the diameter here. We just know the diameter is 710 feet. We're looking for how long the stadium is from one side to the other, so this length is actually what we are looking for. So how long that is from one side to the other is what we're trying to find. So if I were to now put this diagram or draw this as part of a full circle, so take this to now draw a circle. So say I have a full circle. My ground here is like a chord of the circle. So this is like my ground, that's what I'm looking for. And then my 208 is right here. So it is dividing that ground or that chord into two congruent parts. It's a perpendicular bisector. How we are using the information that we're given the diameter of the circle is 710 is because this 208 is actually, if you extend this all the way to the other end of the circle, that is a diameter. So if this is 208, this part of it should be 710 minus 208. So this part would be 502. And then because I am looking for this length, and I know these are two congruent parts, I'm going to label both of these X. Okay, and now I can use the property that I talked about, finding the products of each, or products of the segments of each chord. So I have X times X, so X, well, I'll write it this way, I'll write it out this way. X times X should equal the 208 times 502. So X squared should equal 104,416. And then if I take the square root, that means X will approximately be 323 point, I'll do it to 2 decimal places, 0.13. But that, again, the way I labeled it, that's just half of it. So to find the full length that I was looking for, I want to double that. So it's like this is 323.13, and so is this. So I have to double that to get the full length. So it's approximately 646.26. And that is measured in feet. Word problems are always tough because problem solving is always tough. Problem solving, it's something you have to kind of work through. So keep in mind if you're working through problems like these, because there's some on your practice on your assignment for today, kind of start with a diagram like this. Transfer that diagram into a circle with two chords so that you can figure out what you're multiplying and setting equal to each other. So that's kind of your process if you have to draw a sketch by yourself. All right, we'll move along to the second half of this, which is now if you have two secants or a tangent and a secant, but they intersect in the exterior of a circle. So we just saw if two chords intersect inside of a circle. Here it's if they intersect outside of a circle. So here's your formula for this, and I'm actually going to label to write a different formula out for you. The formula is for each secant the exterior segment multiplied by the whole segment of 1. I should have your attention, please. Side conversation should not be happening. And then that equals the exterior segment of the whole segment of the other. So that's in words. Again, like I said, I'm going to label it so that that makes more sense. So if I were to label AC, so AB, that part I'm going to label little a, and then BC I'm going to label little b. And then for the other secant, I'm going to label AD little c, and then DE I'm going to label little d. So what this is saying is for that first secant, well, actually I'll say this. A and C, those are the exterior segments. Those are the parts of the secants that are outside of the circle. So the exterior segment for AC would be little a, and then that would get multiplied by the whole segment, which the whole segment would be A and B added together. So it's A times A plus B. And that's equal to, for the other one, the same thing. The exterior segment, which would be C, multiplied by the entire segment, which is C plus D. Okay, it's a little different. So exterior segment multiplied by the whole segment. That's if the intersection of the two is outside of the circle. So how do I use this? In example 1 here, we see the 4 parts of each of those secants labeled. So what I usually do is I label on the picture what the whole segment length is. So in this first one, I have this part is x, this part is 8. So the entire segment, the length would be x plus 8. Since they're not like terms, I can't combine them. I would leave it as x plus 8. And then for the other secant, one part is 10, one part is 6. So that whole length is 10 plus 6 or 16. So setting up my equation so that I can find x, for that first secant, my exterior part is 8, and I have to multiply that by the whole length, which is x plus 8. And then that's equal to, for the second secant, my outer part is 6, and I multiply that by the whole length, which is 16. And then I solve that for x. Okay, so I would have to distribute the 8 on the left side. So 8x plus 64 would equal 6 times 16 is 96. And then solve for x. Subtract 64. So 8x is equal to 32. Divide by 8. And x is 4. Okay, so knowing how to set up the equation. Questions on that one? Otherwise, we are going through each or the next 2 examples together also because of how they work out, because of the equations you get. And I will say the way these 2 work out, it's not that I'm just going through it on the notes. You have some that work out this way on your practice also. So for 2, same idea. I'm going to label first of all what the whole segments are. So RU, the whole thing is x plus 9. And then for RY, it is 4 plus 5, so 9. So I would get, for the first secant, my outer part is x, multiplied by the whole segment, which is x plus 9. And that equals, for the second secant, the exterior part is 4, multiplied by the whole segment is 9. And then if I distribute and simplify this, I'm distributing x. So x times x, again, is x squared. X times 9 is 9x. And then 4 times 9 on the other side is 36. So this equation that you get, because I have an x squared and an x term, I can't move this over and then take the square root of both sides, because I would have x on both sides. So because of the x squared, this is a quadratic equation. So we're going to review some algebra here. And in order to solve this type of equation, you can solve it either by factoring or by using the quadratic formula. So I'm going to review factoring with you. For both methods, factoring or quadratic formula, you have to get one side to be 0. So I'm going to subtract 36 from both sides to get the right side to be 0. So x squared plus 9x minus 36 equals 0. And then I'm going to put here, we are going to factor this. Now, factoring is where you're trying to figure out, it's the reverse of FOILing. Factoring, another name for it, is reverse FOIL. So you're figuring out what two quantities are you multiplying or are you FOILing to get this. So I think we reviewed factoring already, maybe even this semester, or I know this year there was one other day we reviewed factoring. If you were with Mrs. Dobbins for Algebra 1, I think you maybe used that diamond method of just setting up your work. So you're looking for two numbers that multiply to negative 36, and then two numbers that multiply to negative 36 and then add to 9. So they multiply to your C value and then add to your middle term, which is your B value. I'll review that also when we get to the quadratic formula. So anybody know two numbers that multiply to negative 36, add to positive 9? Ethan? Yep, positive 12 and then negative 3. So then because the value in front of the x squared is just a 1, the way this factors then is you have your two quantities. The first terms for both are just x. And then one of them with the 12 and negative 3, one of them is x plus 12, one of them is x minus 3. So that's where the positive 12 and the minus 3 come in. And then since this is equal to 0, or why we factor, is you have these two quantities multiplied to 0. That means one of those two quantities must be 0, because in order to multiply to 0, one of them has to be 0. So you set each of these equal to 0. So either x plus 12 is going to equal 0, or x minus 3 will equal 0. And then you would solve both of these. So for this one, I would subtract 12, meaning x would be negative 12. Or in this one, I would add 3, so x would be positive 3. And then you have to think about which answer makes sense. So since x is a part of a segment, or if a segment's length, I can't have a negative length of a segment. So the negative 12 doesn't make sense in this context, meaning the answer to the problem is x is equal to 3. Okay, now that's reviewing of factoring, and I know it's one reviewing problem. I'm also going to review quadratic formula, which we could have used for this. So factoring doesn't always work, quadratic formula does. But if you get this type of equation with an x squared and an x term, you have to either factor or use quadratic formula to solve that. Okay, are there any questions that you have right now, or after we get through that? And the next one, if you have questions, please ask. The next one, similar. I don't want you to think of this as a different formula that we were just using, but this is more specific if you have one secant line and then the other one is a tangent line. So the way to think through this is this tangent line, and if you think of exterior multiplied by the whole segment, this tangent line is the exterior because it's outside of the circle, but it's also the entire segment. So it's the exterior and it's the entire segment. So here you have the JL times the JM, so the exterior times the whole. On this side, it would be the JK is the exterior times the JK is the whole. So it's JK times itself, which you can write as JK squared. So just knowing that when you have a tangent like that, it's both the exterior and it's the whole segment. So you're really just multiplying it by itself. So not a different formula. but just specific when you have a tangent. So if we look at example 3, it tells us that PQ is a tangent to the circle. Find x and round to the nearest tenth. So we have PQ is 8, and then we have our, that's supposed to be a 7. I don't know why, I think it's the writing on the other side. It didn't quite look like a 7, but that's a 7, and this is an x. So this entire length is x plus 7. And again, for PQ, this is the exterior and it's the entire length. It's both. So 8 is both. So this would, or for this segment, it would be 8 times 8, 8 times itself, or 8 squared. And then for this one, your exterior is x times your whole is x plus 7. So we get 64 equals x squared plus 7x. So we have a quadratic equation again that we either have to use factoring or use quadratic formula. So I'm going to get one side to be 0, subtract 64. So I have 0 equals x squared plus 7x minus 64. Now I do just want to show you with this one, if I tried factoring, so we'd be multiplying to negative 64 and then adding to 7. And just for sake of time, I just want to quickly talk through this. This actually can't be factored because the numbers that multiply to 64, you have 1 in 64, 2 in 32, 3 doesn't go into it, but 4 and 16, and then we had the 8 and the 8. And any of those combinations, if one's negative, one's positive, none of them add to 7. So factoring actually doesn't work. So here you would have to use quadratic formula, which I actually have written on the board behind me. So quadratic formula, and I would recommend for you guys to write it on your sheet. I have it on the board, but you can write it on your sheet. So this is when your equation is in the form ax squared plus bx plus c equals 0. That is the quadratic formula you can use to solve for x. So again, this equation, that's where the a, b, and c are coming from. It's the coefficients of those terms. You saw this in Algebra 1, so it's just some review. You'll see it again in Algebra 2. So I want to give you a chance to write that down. But so for this one, what would our a value be? Not the x squared, but the number in front of x squared. Yep, so there'd be a 1. Yep, so the a, b, and c are just the numbers, the coefficients. B would be, B is 7, c is negative 64. And so these are the 3 numbers I plug into here. So I would have x equals, it's negative b, or the opposite of b, so negative 7 plus or minus the square root of b squared, so 7 squared, minus 4 times a is 1 times c is negative 64. And that's all divided by 2 times a, which is 1. And then you would simplify this. I know we're getting short on time, so I'm going to make this quick. So it's negative 7 plus or minus square root of. If you calculated this, because I would start here in simplifying this, if you calculated that, you should get 305. Because we're short on time, I would make sure you can actually go back and get the right values. And this would be 2. So you're actually typing in how that plus or minus works is one of them is negative 7 plus the square root of 305 all over 2. And the other one is if you subtract. So that's how you split apart that plus or minus. And you would type these both in your calculator. This one is approximately 5.2. And this one is approximately negative 12.2. So the negative answer again doesn't make sense to our problem. X has to be positive, so 5.2 would have been the answer. But because we ran out of time, just make sure you could actually get those answers. I will pass out your practice